Have you ever just stopped and thought about how wild GPS is? Seriously, you pull out your phone, you tap an address, and that little blue dot just guides you. It's magic. But the secret behind that magic isn't just clever software. It's actually a 100-year-old theory of physics from Albert Einstein that makes the whole thing work. All right, let's get into how this all connects. I know, it sounds like a weird question, right? I mean, what on earth could a theory about warped space-time have to do with you trying to avoid traffic? Well, it turns out pretty much everything. If you take Einstein's theories of relativity out of the equation, your GPS would just not work at all. So to get why, you have to understand the absolutely insane level of precision that GPS requires. The whole system is built on one simple concept that is incredibly hard to pull off: measuring time perfectly. Okay, so how does it actually find you? Think of it like a giant clock in the sky. There's a whole fleet of satellites orbiting the Earth, and each one has a super accurate atomic clock on board. They're constantly beaming down a signal that says, here's where I am and here's the exact time. Your phone's job is to listen for those signals. By comparing the time the signal was sent to the time it was received from at least 4 different satellites, it can calculate its exact spot on the planet. It's all about time. And I mean, it is all about timing. These signals are moving at the speed of light, so the precision we're talking about is just staggering. If a satellite's clock is off by just 1/1000th of a second, a nanosecond, your location is suddenly off by 30 centimeters. That's about a foot. That's the difference between your front door and your neighbor's. So the clocks have to be almost perfect. And, well, this is where Einstein enters the picture. See, here's the problem. According to Einstein, time isn't this constant, universal thing. It's relative. How fast time ticks for you depends on how fast you're moving and how much gravity you're feeling. And for a GPS satellite whizzing around in space, both of those things are way different than for us down here on the ground. The atomic clocks on those satellites are caught in the middle of a cosmic tug-of-war. You've got 2 powerful effects from Einstein's theories that are constantly pulling time in opposite directions, and the accuracy of your phone's map is stuck right in the middle. Let's break this down. Okay, on one side, you've got special relativity. This basically says that the faster you move, the slower time moves for you. And these satellites are screaming around the Earth at about 14,000 kilometers an hour. That incredible speed makes their clocks tick just a tiny bit slower than ours. But on the other side of the rope, you've got general relativity. This theory says that gravity actually bends time. The stronger the gravity, the slower time ticks. Since the satellites are way up high, about 20,000 kilometers up, Earth's gravity is much weaker up there. And that weaker gravity makes their clocks tick faster than ours. So what does this actually look like in numbers? Well, because of its speed, that's special relativity, a satellite clock slows down by about 7 microseconds every day. That's 7 millionths of a second. Tiny, right? But just wait, because that other effect from general relativity, well, it's a heavyweight. The weaker gravity up in orbit causes the same clock to speed up by 45 microseconds every day. So you've got this -7 from speed and a +45 from gravity. So in this cosmic tug-of-war, who wins? And what the heck does it mean for you trying to find that new coffee place? You might think they'd kind of cancel each other out, right? Nope, not even close. General relativity wins, hands down. When you do the math, the net result is that every single satellite clock runs fast by about 38 microseconds a day compared to us on Earth. Now, 38 microseconds sounds like nothing, but in the GPS game, that's an absolute catastrophe. Okay, so how bad is this catastrophe? Let's put it in real-world terms. That 38 microsecond drift accumulating every single day translates into a position error of about 10 kilometers. 10! After just one day, your GPS would tell you your house is in the next town over. A week later, you'd be in another state. Let's be real. A system that's wrong by 10 kilometers a day isn't a navigation system. It's a random dot generator. Without accounting for Einstein's theories, the entire multi-billion-dollar GPS network would be completely and totally useless. So how do you fix a problem that's literally woven into the fabric of space-time itself? Well, the engineers got clever. Really clever. They basically used Einstein's own playbook to solve the problem, and the solution is kind of beautiful.
Here's what they do. It's like a preemptive strike on time. Before they even launch a satellite, engineers on the ground calculate that precise 38 microsecond a day drift. Then they literally build the clocks to run slow by that exact amount. So sitting on the launch pad, the clock is technically wrong. But the moment it gets into orbit, bam! The effects of relativity kick in, speeding the clock up by precisely the amount it was slowed down. The two wrongs cancel each other out, making a perfect right. It's brilliant.
You know, it's easy for us to sit here and say, well, obviously, but back when they were building this system, it was a huge debate. Some of the engineers on the project actually doubted if this abstract physics stuff was real enough to actually matter in the real world. They needed to prove it. So they ran an experiment. In 1977, they launched a satellite called NTS-2, and they did something pretty gutsy. They launched it with that relativity correction turned off. For 20 days, they just watched and measured. And what do you know? The clock started drifting, running faster and faster, almost exactly by the amount Einstein's math said it would. It was this incredible real-world confirmation. So on day 21, they flipped a switch, turned the correction on, and just like that, the clock became perfect. But wait, it gets even more complicated. See, the satellite orbits aren't perfect circles. They're actually slightly oval-shaped or elliptical. This means that during its orbit, a satellite's speed and height are constantly changing just a little bit. And that creates tiny, ongoing fluctuations in time that have to be corrected for on the fly. And guess what does that correction? Your phone. Your phone is constantly doing relativity calculations. And of course, scientists had to test that too. They put a super sensitive receiver on another satellite to measure this tiny wobble effect. And yup, the real-world measurements matched Einstein's predictions almost perfectly, accurate to within about 2.2%. Just another beautiful piece of evidence that the physics works. Okay, let's bring it all home. What does this all mean? It means that every single time you open a map on your phone, you are personally using one of the most profound, mind-bending scientific theories in all of human history. So here's the bottom line. Your GPS works because it needs ridiculously precise timing. Einstein's relativity messes with that timing, causing an error that would make your location off by 10 kilometers every day. But engineers brilliantly used that same exact theory to prefix the clocks before they even left Earth. A theory about the very fabric of the cosmos became an essential engineering tool we all carry around in our pocket. So I'll leave you with this thought. If a 100-year-old theory about space-time is absolutely critical for your drive to work, what other invisible laws of physics are quietly running your life that you don't even know about?